Hey, hello, and welcome to the show. It's me, John Park, and it is time for John Park's Workshop. And here I am in the Ask an Engineer time slot. So if you're wondering what the heck's going on, if you haven't been here in a couple weeks, here I am. So Phil and Lamore are off and away, so I'm helping out by moving my show from Thursdays to this time slot. That's why I'm here. And when I say here is both a physical thing and a virtual construct that also includes our community. And one of the main ways that we stay in touch with our community is through our Discord. So if you're wondering where's the chat, if you are on YouTube, we've got the YouTube chat up and running, and we're keeping an eye on that. But if you're over on something like Twitch and you're like, hey, there's no chat going on here, check out our Discord. You can head over to adafruit.it/discord and then look for the live broadcast chat channel inside of our server. That's where we're at. And we have plenty of other channels that are active all different times of the day. This one's mostly particularly active during live streams, but we have a bunch of different channels where you can discuss different things that you're interested in, answer questions, look for help on things, show things off, all that stuff on our Discord. So let's see, what are we going to do here? Let me see. We've got stuff in our store. Maybe you want to buy some of it. Maybe you want to pay less than full price. Well, I've got a coupon code for you. That'll do it right there. Swashbuckle. That's just a cool word. Swashbuckle. That'll get you 10% off in the store. So go grab some stuff, stick it in your cart. This coupon code will be good for this evening. I don't know exactly what the cutoff time is going to be. So get some stuff in your cart and check out, put this coupon code right in there, Swashbuckle. Before you check out, you get 10% off. That's good on stuff, physical stuff I mentioned, right? Not software, not gift certificates, not subscriptions, but good on stuff. So head on over there. We have lots of cool stuff. In fact, I'll be talking later about some new products. We also have, I'll mention this right now, since I had an alert set up for it, I never got one of these microbit V2s. They were in short supply. We just got about 50 of them in the store, I think earlier today. So if you want to go grab one of these, in fact, let me open up my browser. Where'd you go, browser? How about that one? Maybe in there. Let me go there before I bring that up. Adafruit. Let's see if this is it. Is that it? Yes, it is. If you head over here and do microbit, you'll see we don't have the bundles or any of that, but the microbit V2 itself, which has been super hard to get, these are in stock. We have 40 of them in stock. They're $17.95. You'll be able to take 10% off of that. So subtract $1.79.5 off of there. I don't know how math works. With this coupon code Swashbuckle, and do some microbidding. I actually haven't paid much attention to it, so I don't even know what's it got on here. Is it an RF52840? I'm not even sure what the processor is. I didn't pay too much attention when they updated it because I couldn't get one, so I was sore about that. But now I have one, so I'm excited to play with that. Works with lots and lots of the accessories that we have, so you can reuse a lot of your microbit things, but this will give you all the newness. So please go check that out. What else? Let me get that coupon code off of there. We had a great show and tell. It just wrapped up. Let me tell you, I was watching that show and tell. I'll tell you some of the things that I saw that looked amazing and awesome. We had Jepler come on, our own Jeff Epler from the Adafruit team, to show a update of a classic guide that Lady Ada wrote back about 10 years ago on making a Next keyboard, the brand Next, Steve Jobs thing when he got fired from Apple. Next keyboard work on a modern USB computer. USB for plugging in your keyboard and using USB HID. So Lady Ada had done that one. I don't know what microcontroller she'd used actually, but it was in Arduino. Jeff updated it to work with, I think it's a CircuitPy in CircuitPython. So he talked about that, showed that off. Really nice looking keyboard. In fact, he's got Lamora's keyboard. He needs maybe to send that back, but he's got her actual keyboard that he used to make that work. Noe and Pedro showed off a really cool looking noodle snowflake. It uses 4 of our LED noodles wrapped into looping sort of petally snowflake shapes, and it's 3D printed with channels to press down the nudes in there and then light them up with a battery. They also showed a little bit of a sneak peek, a little preview of a project Pedro's working on, taking a clamshell case from an old iBook, one of those translucent candy-colored ones, and retrofitting it to show an iPad, to use an iPad instead of the monitor in there and any of the other guts. So he's got some work there that he's working on for his wife who requested this, including some 3D printing of spacers and brackets and things, but the fit looked amazing. Fits really well. Weird. Scott was on to show some work on the ESP32S2 and S3 coprocessor. There's a little sneaky third processor off to the side that is getting some support, almost like PIO-like stuff, to have a little side processor doing work for you while the rest of your code is running. Flavio came on. Connected Ethernet to an RP2040 microcontroller in order to get on the network and augment a ringer to ping a couple of relays, which was really cool. Really nice looking project. Used some neat techniques, including some liquid electric tape. 3D printed a nice looking case for it. What else? DJ Devon 3 showed the couple things, both LED noodles based project. They have a dragon mask and wanted a bunch of ground points using a QT and a little BFF for the driver, and so they made a little proto board, little PCB rather, that has a bunch of ground points, 1 per pin, which makes it really convenient for keeping this dragon mask electronics contained in a small space. It's called Parent because it grounds things, which I thought was cute. And DigiDivin 3 also showed off the TR Cowbell, which is a step sequencer, actually similar to the thing I'm going to show a little later, progress on the thing I'm going to show a little later. And that's getting some updates to accommodate extra ground points on the chips for the matrix. Make It Hackin' showed a bot they wrote, which is to send out tweets for the DigiKey DigiWish, which is fantastic. Automating that every day, you can send a tweet about something you want. People can comment in there, and some lucky winners will get an item up to $100 in value. So go check that out. Also, go over to DigiKey and check out the DigiWish that's happening. Mark Gambler showed a beautiful giant LED board. He's shown this before. This one is a bunch of LED strips. I think maybe it's like 300 neopixels, something like that, running some display matrix code that's super fast now. There have been updates that make this super fast, and he's now got a snowflake animation on a Christmas tree, really fast, incredibly fast looking text. I mean, he's slowing it down, but it's smooth as heck, saying Happy Holidays, Merry Christmas, things like that. And also the dripping icicle demo, just looking incredible with some augmentation of that. And that is going in his window, which is great. It's going to be one of the best displays on the block, I'm sure. And then finally, Jeff Epler came back. We went all the way around the horn, and Jeff came back with a really interesting demo of ChatGPT from OpenAI, which is this bot you can have conversations with, and he asked it to write an Adafruit Learn guide, And it did. It created an Adafruit Learn Guide for creating a automated bird feeder, bird seed dispenser based on, it decided actually to use a PIR sensor, I believe, and a servo motor to let out bird feed. And then Jeff had a conversation with the bot to give it a little bit of a guide review and critique. The bot came back with some improvements so the bird seed wouldn't just all dump out, but actually could close. And then even asked it to rewrite it in CircuitPython since it was originally writing it in Arduino, which may have been an example it found on the net. I'm not sure exactly how it works. And that's when it got a little creative. It wrote some fictitious CircuitPython, but if we keep plugging away at it, it'll maybe get to the point where it can do some actual legitimate guide writing for us, and then we're just going to be sitting back drinking martinis. I don't know. So thanks everyone for coming on to Show and Tell with those great projects. That was a lot of fun. Let's see, next up, I've got a show on Tuesdays. That was just yesterday. It seems like it just happened like hours ago. And that's JP's product pick of the week. And on this show, I like to show you a new product, give you a humongous 50% discount on it, do a little bit of a demo to show you how it works. And this week it was this one right here, this multiplexer. Really cool, PCA 9548 8-channel I2C multiplexer. And here's a little demo or a little 1-minute recap. Check. The PCA 9548, an 8-channel multiplexer. You can use multiples of the same board that have a conflicting address on I2C. I have a Qt Py plugged into the PCA 9548, and then I have 2 of these VEML 7700 light sensors. There is no jumper for addresses. We just have one address to work with. So I've got 2 of them plugged in here. This is a little graph that's showing the light sensor reads from the 2 sensors. I've got one facing down and one facing up here. So now you'll see a big difference between these. And let's say my light comes around to the other side, and now it's pointing up at that bottom one. So now we can detect light in 2 directions with this really great light sensor. It is the PCA 9548 multiplexer for I2C. Yes, in fact, that's what it is. There was actually some interesting discussion in the chat during the show, and we were talking about, the creative engineering team we were talking about earlier, about what sort of, as Ann Barella said, what sort of inception could you create by linking enough multiplexers to enough multiplexers? Probably you would create different phases of time as it slows down further and further and further. But not sure what the hard limit is on it. Theoretically, someone suggested you could do something like 2048 sensors on enough multiplexers, but who knows? So if anyone wants to try it, I would love to see. Please write up your findings on that. Right. So let's see. The next thing I want to do is a little CircuitPython parsec. So let me get set up for that, and away we go. CircuitPython All right. So for the CircuitPython parsec today, I wanted to show another way to time things that's even more precise than the last one I showed. And this is with using the ticks inside of the supervisor library. So these are similar to the way that we use time monotonic, but even more accurate. So what you can see here, if you look at my console, right now when I run this code, it tells me that basically 0 time has elapsed because all I'm doing is checking the time and then repeating the time or printing out the time. So what I'm going to do now instead is I'm going to make one print statement. So you can see my program imports the supervisor library. It checks what's the current supervisor ticks milliseconds. It then is going to do something, going to have it print a line, and then it's going to stop, create a variable that's the end time, and then I'm going to print out the one subtracted from the other and turn it into a decimal, which is a little easier to see. So if I save this, you can see it now takes 0.001 I believe milliseconds to do this. Now, by contrast, I'm going to import a fairly robust library. I'm going to import NeoPixel. Watch when I hit save. Now you can see that takes 20-something times more time. Now, you may not always need to time such precise things, but one of the interesting things about using these ticks is that they can give you more accurate time over long periods of time, such as running a thing for days. This tends to stay a little more accurate than some of the other methods. And so that is how you can use ticks to time things in CircuitPython. And that is your CircuitPython parsec. Wow. All right, so yeah, that's part of our continuing series of timing stuff in CircuitPython. Let me know if you have other methods that you like or that you'd like to see. Thanks to ToddBot for this example, this simple example of getting this up and running. And that example is actually available over on Todd's GitHub in the CircuitPython tips and tricks page. So maybe he can throw if he's around, he can throw a link up to that in the chat over on Discord. So let me get that out of the way there. And what's up next? Hey, how about we take a look at, let me go grab another window that I have prepared here. Oh, hey, I'm getting another tip here. This is from Jepler. Let me throw up my Discord. It says use the Adafruit ticks next time. Okay, good. This gives me one more thing to show. So, and I'd love to know. Maybe we can talk offline about the differences between Adafruit ticks and I guess the MicroPython ticks that I was showing there. All right, so let's see. What I wanted to do next is got to check and see. Do I have? I'm going to copy a URL over into the Chrome that I had up here. So let me paste that into here. Because, as you may know, CircuitPython is code plus community. And one of the best ways we have of celebrating that is with the Python on Microcontrollers newsletter. So this is a weekly newsletter. You can subscribe to it by going to adafruitdaily.com. Just put in your email address, request the newsletters you'd like to get in your inbox. And you can also go and check them out here on the webpage itself. Right on the homepage is a link to this. And this is this week's episode or edition of the Python on Hardware newsletter. And I'll just point out a couple things that I thought were notable from this week's edition. First of all, there are now 100 CircuitPython Blinka compatible single board computers. So this is things like Raspberry Pis and Onion Pis and Rutabaga Pis and Asparagus Pis. I don't know all the different ones, but if you're like me and don't know all of them, that's okay, because this newsletter has you covered. You can go and click on the link here and check out all of the Beagle, there's another one, all of the different boards that are now compatible with Blinka. Let's see, also we had, let me check my notes over here, move this out of the way. Oh, there was an Advent of Code calendar. This looks interesting. These are some small programming puzzles that you can open up, one little nuggety, bite-sized, little delicious puzzle every day as an Advent calendar. So there's a link there that'll take you to that. Speaking of holidays, check out this, you guessed it, Hanukkah lightsaber. So this is great. This is a Circuit Playground Blue Fruit and a strip of 30 NeoPixels doing a persistence of vision method where you can use long exposure photography and draw some different Hanukkah-based things in the air and take cool long exposure photos of them. There's a menorah and some dreidels, and there's a nice little explanation of it in here, and this was found on Instagram. And by the way, if you find things that you think belong in any of our newsletters, there's a link at the bottom that'll tell you how to go and submit those changes or submit those news items. This is also another nice one. This is a 3D printed Plex server using a Raspberry Pi, but it also uses CircuitPython, I believe, for all of the display stuff to give you system statistics and other information, IP address, temperature, and other readouts there. So really cool looking Plex server or media server. Here's another really nice one. This is our own Toddbot. Everyone's Toddbot. He's not just our own. He's the world's Toddbot. And Toddbot created a really cool Pico Touch synthesizer, another in his ever-growing series of small PCB-based synthesizer things. This one has an octave keyboard of capacitive touch and also has reverse mount NeoPixels pointing up. And he's got some tests up there. This was a link on Mastodon. You can go there and check it out, or just enjoy this GIF of Todd touching it because it's a touch synth. Let's see, another one actually somewhat related was this one, which is Bobricious, if I'm getting that name right. Created this ArmaChat touch computer, and it also uses Touch I/O to create this full QWERTY keyboard with backlighting, and it's a PCB with a underglow type of technique where the solder mask has been told not to go. And it's a really cool looking project. You can go check that out on Instagram and then find other links for more information. And the last one I thought was a really cute Clippy there. And then the last one that I was going to call out, but of course you can see there's lots and lots of stuff here I'm skimming over, so you should go check it out yourself, was, where'd it go? It was the Pine 64 Pico-sized single board computer. I think I blew past it, didn't it? Where'd you go? Where'd you go, Pine? Nope, nope, I'll keep going. Keep going. That was a little macro pad. There it is. So this is I don't know much about this, and I must admit I haven't followed the link yet, but that is a Pico form factor single board computer. So if you want to learn more about that and all of these other interesting things, I'll just tease. There's another little new board right down there, the M0sense RISC-based computer or microcontroller. These are all in the Python on Microcontrollers newsletter, so go check that out. All right, let me jump back here and grab a little water if I have any left. Let's see. What else have we got going on here? Another thing I will mention, I've mentioned it before, but it's the return of AdaBox. So AdaBox will be coming back next year. As you know, due to the global supply shortage of parts, we didn't do any in 2022, but 2023 is going to be the year of the AdaBox. We have a lot of great stuff planned, so come in, check out the adafruit.com/AdaBox site. You can sign up there to be to subscribe or to be notified when you can subscribe, and you can also subscribe other people. Let's see, the next thing I'm going to do is Learn Guides. So we have some new Learn Guides in the Learn system. You can head on over to learn.adafruit.com, and you'll see we've got thousands, over 2,000, closing in on 3,000, I think it is, guides in the Learn system. Here are some new ones since last week. So Liz wrote a guide on the QD, so Stemma QT 5 volt to 3 volt shifter breakout. It's just a simple level shifter so that you can use things in the quick side of the ecosystem with little breakouts that are using that 4-pin connector that don't necessarily level shift on their own. You've got a 5 volt thing on the other side or a 3 volt thing. So there's a little guide about that. Lady Ada wrote this guide on the SPI FRAM breakouts, which I didn't know anything about FRAM, but now I know a little about it. FRAM is a type of RAM that's really useful when you want to very quickly write data that is persistent, such as the save state on a game, so that the user can power the thing off. You've got a little bit of data that's been written to it that you can pull back up when you power back on. And you don't need a battery. You don't need any batteries to save your state like you would in an old game cartridge. This will write right to the FRAM. There is a guide from Kattni on using the Mastodon API with CircuitPython. There's also this, I love the GIF here. You can see this GIF animation of Aaron's new guide on NeoPixel remote IR control with WLED. This was something entirely new to me. You can check this out. There's a really great video to watch, actually, that will explain it all. But Erin builds these beautiful LED pieces of art and costume pieces, and in this case is lighting up an aquarium that she does some mermaid swimming in, I believe. I think this was that aquarium. And this is a guide on taking NeoPixel strips and communicating using a sort of standard off-the-shelf IR remote and this WLED library and web page that allows you to create or use a library of existing animations and get them running on your microcontroller. So it's sort of a melding of worlds of commercial NeoPixel strips and the NeoPixels, so you can build your own microcontroller-based projects the way you want to. So go check that out if that's interesting to you. Here is the LED noodle snowflakes that the Ruiz brothers were showing off at Show and Tell. So you can go, look at that, that's beautiful. You can go and check that out and learn how to build your own. It's just a bit of 3D printing and some LED noodles, a little bit of soldering, and you've got a really large-scale snowflake to check out. The Bluetooth TV Zapper guide, this was the one I was working on last week and the week before. This is going to show you how to use a Circuit Playground Bluetooth, or Bluefruit rather, and our IR Stemma breakout board, which has a couple of high-power IR LEDs on it, and you can communicate to it from your phone in order to have it send some turn-off commands to TVs, turn off and turn on commands to TVs remotely from a safe distance. And last guide in here, we mentioned the Next Computer Keyboard guide that Jepler showed off in the Show and Tell. Here's the guide on how to build your own in case you find yourself either with a Next keyboard and you want to use it in a more modern computer, or if you're just curious about the process of creating something like this. It might be helpful for you if you're doing other investigations into obscure peripherals. And those are our Learn guides. All right. Let's see, I'm just going to check in with the chat and see what's going on over there, as well as the YouTube chat. Let's see. Go back to this view of the world. Oops. Here we are. I'm bringing my Discord a little closer. Let's see. DJ Devon3 said Kattni's Mastodon API guide is excellent. That's great to hear. Yeah, what's WLED? I should dive into it further so that I can explain that. But it is its own thing. It's kind of like Fast LED. If you're familiar with Fast LED from the Arduino world, it's a easy to use LED library that gives you really fast, beautiful animations. And in this case, you don't have to code them yourself. You can pick from UI elements or pre-baked animations if you want. I need to look at that guide closer and try it out, actually. That was really cool. All right. Let's see. What's next? I'm going to actually take a moment to do a bit of a gear report thing. This is kind of cool. This is, let me see, let me jump back to this page over here. This is something that I just picked up. Actually built it for someone. This was a kit to build this little Eurorack module. And the reason I was interested in it is this is based on a Pro Trinket 5 volt. So if you take a look at this little module's build guide, you can see here it's kind of a nice build. It uses mostly surface mount components, which I really like on these kinds of builds, so you're not constantly threading resistors and capacitors through and clipping their tails. So it's a reasonably intermediate level build. If you're getting a little more comfortable with doing some surface mount components, this is a cool one. So it's got a couple ICs on there, got some passives, a couple through-hole capacitors, and then as you can probably tell from that outline on the board there's a microcontroller that's going to get plopped into there. There go the 3 potentiometers, 4 jacks, some switches, Really beautiful looking, nicely done aluminum faceplate. And then here comes the Pro Trinket 5 volts. So what does this thing do? It is a module that will generate random melodies for you that are musical, in that they are quantized to a musical scale. So they can be anything from diatonic, semitones, to certain intervals like only octaves or thirds and fifths or sevenths and ninths. And it takes in an impulse, a trigger that says, okay, generate a new one. And every time it gets a trigger, it has a bit of a roll of the dice to see what note it gets and if it's going to trigger it or not. And then there are some controls for choosing the length of repeatable looping patterns, how many octaves it should be allowed to use, and so on. So I wanted to show you this and give you a little bit of a demo of it. I got the module built. I'm actually sending it off to the guy who asked for me to build it for him tomorrow. And here you can see there's a little user guide to it. I'm going to actually hold, maybe I'll keep that open just for myself so I remember what some of the secondary functions on it are. But let me go to my downshooter here. And I'm going to move a couple things out of the way and show you this. And actually this is I've got a few modules to show in here that I think are kind of interesting. And if you're wondering what is this and you haven't watched my shows before, I often show these Eurorack modular synthesizer thingies, and this is that. So I'm gonna focus here, and then I'll show you the downshooter. So I'm not trying to focus while you're looking. Okay, so here is, move this over to the side here, and I'm gonna plug in a audio jack, and I've got a little amplifier back there behind me that might reach. It'll just reach. All right. So what's going to happen here? I'll just focus on this guy. I'm going to give it a little bit of a regular clock. So there's going to be an incoming impulse that says trigger, do something. So you can hear right now, I've got this loop going. I think it's 8 notes. I can change the step size so I got 4 of them. I can go all the way down to just 1. So this is a little loop that it created, and then I said capture that. So it's just repeating that loop, but I can change how much of the loop I'm going to listen to. And there's a shift control here that lets you sort of slide through the loop, pick a different part of the loop to go through. I'm going to turn off looping. You'll hear it change now because now it's able to pick from the constraints that it has of a certain range, octave-wise, as well as a scale. So if I change the scale, now you're hearing different intervals in that scale. And sorry, I need to reset this little trigger, which I'll talk about. I'll set it fast. Let me slow it down a little. And now I'm going to lower the odds that it actually triggers. So now it's got a little bit of uncertainty. Is it going to pick a note or not? We can go from 0 to 100%. So on 100%, it just always plays a note every time it gets a trigger. And that's pretty much all I wanted to show about it. The outputs that it has are the volts per octave that my oscillator is using, and the gate that it sends out to say, yeah, I triggered, so we can open and close a little VCA, a little amplifier. One other input it has is it can bring in a volt per octave itself from a keyboard, so you can kind of shift the whole thing around, play root notes. And this guy, let's talk about this guy now. This is a side thing. This is from Todd, our very good friend Todd Bott. This is, I'll bring up his guy there. This is called the Trinket Trigger. So we have old and new trinkets. We have one in here written in C, and this one is in CircuitPython, and they're very good friends. So if I bring this up for a second here, you can see todbot/trinket_trigger on GitHub, and you can build your own. There's all the open source files that you need to create that. So this one's running CircuitPython, and it's got, if I turn it off here, you can see it's got just a little trinket M0 running on there with CircuitPython. And then this one here, I'm going to take it all apart now because I got to box this up and ship it anyway. So I'll show you what this whole little module looks like. And pull its little ribbon cable for power. So there it is. There's a Trinket 5V, our good old friend right there. And the other thing I'll say, in case this is a little confusing to you, is this isn't actually creating any sound. This is really playing the piano for you. It's just deciding what notes to tell something else. In this case, this braids module here was what I was using as the actual sound maker. But that wants to know, hey, what pitch should I play? And that's what this one's doing, is when is it going to play it and what pitch. And that kit, you can get that on thonk.co.uk. I think they're back-ordered right now. But just check for the Seb Songs odds module, and they have a few different modules, but I thought this was a really neat module, really cool, fun to build. So if you like to build your modules, you can also build things cheaper than you can buy them in many cases. This was a nice one to build. So there you go. That's the odds module. I'm going to set that somewhere safe, and that's going to go to its owner, and I will miss it because it's a really cool module. I'll show this one off sometime too. This is a neat little kit from Tom Whitwell, Music Thing Modular, and it is an overloading drive module, like on an old amp, using an incandescent bulb to gnarl up your signal, like a gnarly distortion. So, all right, I'm going to unplug this and set that over there, and let's. Liz says, yay, knurlies. These are these cute little knurled screws for being able to move modules quickly without grabbing a driver. I like those. Okay, so let's see, what is next? Hey, how about new products? Let's do a new products. So, new products. Let me open up not that window, but this one. Okay, we got 3 new products this week. And here they are. Get ready for it. There we go. So 3 new products. The first one is this pack of the little slide potentiometer knobs, or rubber nubbins. And I thought I had one right here and I forgot it. So these are the nubs that come on some of our potentiometers. I think when you buy some of our slide pots, they come with these little nubs. But maybe you lost one. Maybe you need extras. Maybe you've gotten some slide pots that don't have them. This will solve that problem for you. It's cheap. You get a pack of 3 for 95 cents. I'm just going to check one place real quick. 2 places real quick. Hold on. I have some little demo projects in a couple bins right here. If you've ever wondered what's all that stuff behind me, some of it is these demo projects. And do any of them have a slide pot? Oh, wait. Hang on. No, I don't think they do, actually. Oh, wait. Hold on. Last one, I'll check. No. All right. Sadly, I don't, but you get the idea there. They're little cute nubbins that allow you to not put a dent in your finger, because what the slide pots have is a little metal stabby bit that you don't really want to hurt yourself on. Next up, this one I actually do have. This is, oh, a little question from the chat, DJ7-3. So whatever happened to that line on the Alps cap touch nubs? We haven't found anywhere to buy those yet. I bought a few off of like an eBay seller in Germany or something like that, but we haven't found any of the capacitive touch ones in the wild from a wholesale distributor. Next, we've got this 2.8-inch TFT LCD with cap touch, and this has iSpy on it. I've got one right here. Let me show you this beautiful looking display. We can do an unboxing of it. In fact, I don't have any code running on anything that I can actually start it up, but maybe I'll have that next time. So let's take out this. By the way, if you're not aware of this, usually this pink bubble wrap or pink bags are anti-static. So that's why you'll see a lot of Adafruit stuff come in that. It's a little safer than your average plastic. This has a little peel off on there. I'm going to leave that on. So this is a gorgeous, what did we say it was, a 320 by 240 pixel display? I think it is. Just checking here, we'll have that listed. It is a mystery. I think it's 320, 240. It's probably in the Learn Guide. We can go check that in a second. This is a iSpy compatible, so you can use this little ribbon cable here, little ribbon connector to plug that in rather than dealing with all this jazz, all these pins here. It has the SD card slot on it. That also goes over the iSpy ribbon cable. And this has capacitive touch, so you can use this for little interactive projects, drawing, make a display that you can pick buttons on, all those good things. So this has previously been, I think we had a version of this without the iSpy connector. Now we've got iSpy connector on it, as we iSpy connector all the things. And yeah, Kiyoshi in the chat says, yes, it's 320, 240, or 240 by 320, if you go that way or that way. So that is our new display. And let me bring this window back up over here. Last thing, whoa, what happened to, go back to products. Oh, we got new things. We got new things that I'm not even aware of. Okay, we'll go back and play with those. Those have gone in the store since I was prepping for this. This is a cool one. This is actually more info and more coming soon. But this is a product that's a collaboration between Adafruit and Kelly Heaton, which is I think it's a 6 oscillator songbird song generator. So it creates bird song using I think it's 5A stable oscillators and a 6th one that's a different type of oscillator. This is gorgeous. You can see this beautiful PCB here. And Kelly has done a bunch of projects in the past about birdsong and using a deepfake algorithm to analyze the birdsong that our oscillators were creating to find out if it was similar to a bird in the wild, which it is. It's actually the nightjar, which is how this got its name. And this one also has some inputs that'll allow it to be controlled by outboard gear such as Eurorack. So for example, I am guessing that this odds module right here could be a very interesting way to inject some different notes into the birdsong, sort of fundamental pitches to work from, which is pretty cool. And what else? That's all I'm going to say about it. So this, once we get one of these in to demo, we'll show it to you. But go check out Kelly Heaton's work if you're interested in more about these gorgeous bird song generators. So that's a coming soon. If you want to get ones, I'm not sure how many we're going to be selling, but if you want to get one, you can click on that Notify Me link in the description there and put your email in, and then you'll find out as soon as that's available. So new stuff. Hey, these are some new snap action wiring block connectors. These look great. I know nothing about them because I'm seeing them right now. They remind me of the Wago connectors. And we have a 3 to 9 wiring block connector. We have a 2 to 6. So this is a way to sort of Y splice off one into multiple. So you can go from 1 to 3 with 3 different inputs, or 1 to 3 with 2 different inputs, or just 1 to 1. And I'm going to pick some of those up. Those look great. I love these types of connectors for wiring up projects. And then last one on here we have is a MOSFET driver for motor solenoids, LEDs, etc. This is a JST 3-pin. I believe this is similar to one that we have had in the past for our bonsai, which is a water pump driver for plants. So that's another one that's coming soon. And I'll find out more about those because those are pretty cool, pretty useful for driving powerful stuff without having to construct your own circuit. And that is all I can say about new products. I don't know how she does such great songs every week. All right, so next up, this is a great time to remind you, having just looked at new products, a great time to remind you that I've got a coupon code for you right there. So if you want to order any of that new stuff, the stuff that's in stock, unfortunately this won't help you for the stuff that's not yet in stock or out of stock, but that'll do it right there. That'll get you 10% off in the store. All you got to do is swashbuckle, and 10% off coupon code will work on any of the stuff you can get. It's not good for gift certificates, subscriptions, or software, but it's good for real stuff like snap action connectors and nubbins and a really gorgeous big touchscreen TFT display that has iSpy on it. So go load up your cart with cool stuff. One thing I forget the details on, and probably I should commit these to memory or add them to my notes, is the free stuff that you can get when you order. If you order more than $100, $200, $300, we have different free things that get thrown in with your order. So it sometimes pays to gang up. Wait till you have quite a few things you want to get, and then you'll get some free stuff thrown in the order, which is cool. So yeah, Swashbuckle will get you 10% off just until the end of tonight or something. Maybe midnight, maybe sooner. Oh, that's a good reminder, DJ Devon 3. The Christmas shipping deadline is getting close. Let me see if I can, if I refresh the shop page, if it'll bring that banner back. I closed that banner. How do I get back to that banner? Let me see. More announcements. No, that won't do it. Hold on. Oh, Jepler found it. It's at adafruit.com/holiday. Let's put that on. Thank you. adafruit.com/holiday. You can guess a lot of these things, I should have guessed. You can guess a lot of these URLs, which is nice. Reminds me of the old-fashioned web where you could just think, hey, that's probably what they called it, and it is. So the shipping deadlines for holiday 2022, that's this year right now. Domestic orders for delivery by Thursday, December 22nd. UPS first class priority is tomorrow. UPS ground, or rather Postal Service priority, first class, is tomorrow. Ground is Monday. 3-day is the 16th, that's Friday, next Friday. 2-day you can do on the 19th, next day you can do on the 20th. International orders, we are out of luck unless you want to do DHL Express Worldwide, which is going to be this Monday, and that's no guarantee that it'll arrive by December 22nd. So deadlines are coming up. If you want to get some stuff, get some stuff. Oh, thank you so much. Kiyoshi in the chat said half-size perma-proto board is your freebie with the $100 level. Keyboard is the next one, and then Circuit Playground BLE. And free ground shipping on the perks. Thank you. I bet those perks are here somewhere too. Hey, I'm going to try this. Let's see what happens if I do adafruit.com/perks. Nope. It was worth a shot. Who knows? Who knows what that is? What's our URL for that? It's probably in here somewhere. These are things I should know, right? Sorry. Okay, let's see. Next up, I wanted to dive back into my 16-step drum trigger sequencer. Oh, it's free, adafruit.com/free. Thanks, JetBlue. So head there to find out, or check out our chat. So let me show you my overhead over there. I'll put my little head here. So you can see the beast has grown. So I've got the Keybor 2040. I have the AW9523. Is that its name? I think it is. Excuse me, which is the constant current driver that I'm using to light up 16 LEDs. If you remember last week, I had been planning to use PWM, and I thought I had 16 PWM I could use. I did not. There were only 15, I think it was, that I could use, or 14. So I switched over to using GPIO. I do have enough GPIO on the KB2040 to just do direct. I don't need a breakout for that. So I got 16 normally open switches there using the step switches there as buttons. And I'll show you the code for what I'm using right now. Question, Toddbot said, is that sitting on top of a CRT? That would be amazing. I wish I had dug out a big hole in my workbench and put a CRT. It's not. It's actually an old VGA LCD, very old. IBM Think something. What do they call this? Think something, not ThinkPad. But yeah, so that's a copy of virtual modular software. And by the way, I always like to mention, even though I love showing off this hardware, these hardware Eurorack modules, you can get into Eurorack for no cost at all other than owning a computer. As long as you have a computer of some kind, which many of us do these days, you can download VCV Rack for free, and there are probably other things out there these days and forks from that, but VCV Rack is what I have there. So that works with the Eurorack standards and some of the modules. ThinkVision, thank you, ThinkVision is the monitor. So I've got a copy of VCV Rack running on an old MacBook Air, ancient, like 9 years old or something. And I'm using that KB2040 as a MIDI input device. Now, this is the next step in the evolution. So you can see I've wired everything up on the breadboards there. And so I have the switches and their LEDs, and I just have them each sending their own unique MIDI note. So it's acting basically just like a MIDI keyboard right now. Next step is I'm going to work on turning it into a proper sequencer with maybe 4 channels of drums. So I'll be able to have 16 steps of bass drums, 16 steps of snares, 16 steps of hi-hats, 16 steps of open hat or something like that. But just to get the sort of proof of concept going, this is what I got. So let me run over there, and I can just do a little bit of a brief demo, and then we'll look at the code running on there. So let me get that view. That'll work. And I'm also going to replug my little amp here into that laptop. Yeah, I'm a fan of having old monitors around that you can just set stuff on and not really worry about scratching it up or anything like that. So here is, you know what, I'm going to open up the chat right here. Tell me if the volume needs to change on this. I'm just going to open up Discord. Here we go. So these modules essentially all just want to get a trigger impulse. And when they get one, they are sort of little self-contained drum voices. And each of these has 2. So I've got 16. So top row, 1, 2, 3, 4, 5, 6, 7, 8. Bottom row is the second half of these. 9, 10, 11, 12, 13, 14, 15, 16. I had to get 2 of that one because it's big. And the way this is set up is really similar to the project I did that was the 8x8 grid using the NeoPixel grid to drive using this, I think it is Stoer, S-T-O-E-R, Stoer Melder, which allows you to bring MIDI in and just trigger stuff with it. So it has a nice little setup. There's no wires coming out of that one, but it's what's triggering all of these little trigger push buttons. So let me see if I can hear anything. Uh-oh. What'd I break? Let me see if this is unplugged, if it works. Okay, that's working. There we go. So I can turn that up a bit. Loose wire, okay. Get that out of the way there. So what you'll be able to see here when I zoom in a little closer just on this top row, in fact. So when I hit any of these, you can see, first of all, I'm lighting up their LEDs nice and bright. So with this constant current driver, it's really nice. I'm telling it I think I've got it remapped to values of 0 to 255. So this is, I think, at a value of 5, or maybe even 2, is this sort of dim light. And that brighter one is a value of 20. And if I do it to 200, it's super, super bright. So those will be things I use to show which steps are lit up in the sequencer versus what note we're on or what beat we're on in a measure. So. And the way I set these up, since these are these pairs, I just have kind of tuned the same drum, 2 versions of itself for variety. That makes me want to get a bunch of tom drums and do the Phil Collins thing. Except I don't have 4 toms set up. So that's pretty much all it's doing right now. The idea will be to, again, set this up so that I can have that looping just like a 808 style drum sequencer. I'm going to add using I2C, I'm going to add over Stemma QT our little rotary encoder so that I can change which track I'm using, and probably a little OLED display. So this will be really similar in a lot of ways to Toddbot's 8-step Pico sequencer, except I'm not doing pitch stuff, I'm just doing triggers. So just whether a trigger is happening or not on different instruments, different drum instruments. So let me take this here, unplug this little guy right there. You can see I left a gap in the program just so I can set my device on top of it there. And let's take a look at what that code looks like over here. Oh, you know what? Let's use this setup. This will work well. There we go. Oh, that's too many of me there. And I can expand this a bit. One second. Ooh. That should work. And what I'll do is just open up the code.py that's running on oh, I broke it. Is it going to recover? It might recover. It might not. Oh, darn. That works a little differently than Adam. It didn't like me closing that. Hold on one second. Let's see if we can fix this. Oh, no. All right, maybe I've got sound and picture. Let's see. Thank you, Blitz and Kayoshi and Glenn, for letting me know there was no audio. Lara's gnawing on cables again. All right. So all I want to show you here is the way I'm using this AW9523 constant current driver breakout to control all 16 of these LEDs, and then the switches to send out the MIDI signals that I'm saying. So you can see here, when I click these, they are lighting up a little brighter. So in the code here, I've got some little setup here where I'm setting up all my switches, and I'm using keypad with those to read those. And then over I2C on the board stemma I2C port, I've set up the LEDs object as this AW9523. And then you set two things, the LED modes to constant current mode using this little bit mask, and then the LEDs directions saying that they are outputs. And that's because you can use this as a input if you want to use it with buttons. You can use it as a sort of more simple output, or you can use it as the constant current mode. So I'm telling it I've got 16 LEDs to go ahead and loop through. Here you can see these are these brightness values that I set. So 220 and 200. You can see that's at 20. So particularly for this camera, but even for your eyes when you're working on these things, you just don't need it very bright. One of the nice things is that you don't need to put resistors in line with these if you're using constant current. However, and I need to figure out if there's a way around this, when this starts up, it does light them all up, and and it's crazy bright, and I am thinking I probably should put some inline resistors just to avoid the scenario where it draws too much current on startup. Then I'm doing some MIDI setup, and then here's the main loop of the code. So keypad makes it so easy. You just say switch is the name of switches.events.get. So just checks through, it pulls through all of the pins that I told it are switches and said, hey, did something get hit? If something does, it'll return, yeah, there's a thing called switch now. And if it's a pressed event, then I'm finding out, okay, switch.keyNumber, which one was it? Then I'm sending out a MIDI note based on whatever my 0, 1, 2, 3, 4, 5, 6, up to 15, and then I'm adding to that 35 just to get the MIDI note numbers up into the general MIDI note range for drums. So if you're driving a general MIDI thing like a sound card or a simple synthesizer, web synth, on channel 10 there are drum sounds, one per. It's not pitches, it's one drum sound per note for, I don't know, 40 notes or something like that. So I have this in that range, but I wasn't using that over in VCV Rack. And then I set the constant current driver to that mid value, which was 20 for that ID number. So my switches and my LEDs have the same little numbering set, 0 through 15. And then I'm just, for my own debugging right now, printing out if something was pressed or released. And then when I release something, it sets the note to off. And I'm also setting the velocity to 0, which is redundant there. And then I'm setting the constant current back down to its dim level, which was 2. So that's what's going on with this. This was the sort of the big improvement over last week, was deciding to go ahead and use this constant current driver for the LEDs since I had run out of PWM, and it's working great. So I'll be updating this, hopefully finishing it up soon by getting it to actually work as a running sequencer. Probably using ticks, maybe Adafruit ticks. We'll find out. And I'll be writing up a guide for this, and then we'll have a cool little 16-step sequencer that we can use. And hopefully the guide is also useful for you if you're doing other types of projects and you want to use maybe a bunch of these switches, drive the LEDs, read the inputs, and then do something entirely different with it. All right, so let's see. Let me know if anyone has any questions in the chat. And I can get to those in a moment. Before I do that, let's see, do we have any other business? That might be it. That might be all the business that I had to get to. So yeah, let's take any questions you might have that I can answer for you. I'll wait a second since I know there's a little bit of a lag between broadcast and the YouTube picking it up. And I'll scroll back. Let me scroll back through my Discord now and see if there were any questions that I missed in the course of the show. Yeah, people heard, oh no, right before my stream died earlier. It's asking a lot of the poor computer. Glenn Burbeck says, tactile touch is nice and cool, but all could be done by cap switches or touch panel and LCD. You're absolutely right. Let's see. Oh yeah, someone was Kiyoshi was asking about this ThinkVision monitor. I think that's 17-inch. That's a 17-inch. And has a few different VGA resolutions on it. That was a freebie. I got that through, someone was just donating it, which was nice. And let's see, anything? Going once. Going twice. Oh, Jeff Jepler posted a nice difference between microbit V1 and microbit V2 link. I'm going to check that out. See, does it have any? Oh yeah, this looks like a good site. Let me bring this up. So check the chat. You can ask Lars some questions. I don't know if he can answer them. He's mostly just terrifying. Whoa, that page went weird, didn't it? Yeah, I don't think I have a good way to recover. Okay, I'm not gonna tempt fate by going to that. But yeah, check out in the chat. There's a link there that actually, yeah, Jepler posted of differences between the different microbit versions. But yeah, those are in stock. Does Lars have family? Yeah, Lars is someone's child, I think. I don't know. Was Lars constructed in a lab? We don't have a lot of details, honestly. But look up Fugler online and you might find out. Does he miss his mom? Of course he does. He's not a monster. Okay, he is. All right. Yeah, Dave Bauer says these step switches are perfect for getting precise performance on drum hits, just like the old Roland synths. Yeah, the Roland ones, by the way, those used a Alps tactile switch with just a custom switch cover on it, and the LED was just coming out of the PCB. It wasn't a self-contained thing like our cool little step switches that we have nowadays. These things are great, and we've got a little breakout board on there. If you didn't know, I can unplug that. So USB cable doesn't want to go. I've got these on these nice breakouts because the switches and LEDs, the pins are all kind of on top of each other. It wouldn't work with regular breadboard or PCB spacing. So we've got these little breakouts. In fact, let me show those. Can I? Oh no, I'm gonna break my internet if I try to do that now. Lars is a bit of a cyborg because he's got electronics in him to make him talk now. All right. Well, hey, thanks everyone. I don't want to take up any more of your time. I do want to, I forgot last week, very important end to the show, but penultimate end to the show business is this coupon code. If you are buying stuff, remember you've got deadlines coming up on shipping. So if you want to order stuff tonight and you want to save 10%, just type swashbuckle in on your way out in the coupon code slot. That'll get you 10% off. And I will say thank you so much for stopping by for Adafruit Industries. I'm John Park. This has been John Park's Workshop, not Ask Lars. And this is your moment of Zorro.
you